Okay, so we're going to continue what we've been talking about with 12.6 or 12.3, which is just finding values of different trigonometry. And this is going to be about finding exact values. And so just kind of as a quick primer for this, the way that we're going to really think through this is by remembering that whenever we have any kind of angle, we're going to have a reference angle, and that reference angle is going to be with the horizontal. And then we need to think about the value of the coordinates, x and y, and then the value of the what we call radius, which is the distance that coordinate is from the center or the origin. Sometimes it's easiest to go ahead and let R be 1, and we'll learn more about that later. But for the most part, what we're going to do is make it what's convenient for us. We'll pick one of the three values, and then we'll figure the rest of them out based on, and all of these are going to be based off of either knowing two of the three sides and being able to find the rest, or a special right triangle like a 30, 60, 90, a 45, 45, 90, or looking at the 90, 180, 270, 360 degree values. Okay, so what we're going to do is something like this. Find the exact value of all 6 trig functions for theta equal to 150 degrees. Now, before we start that, remember what our definitions were. Sine of theta is going to be y over r. Cosine theta is x over r. Tangent of theta is y over x. And then we do the reciprocals. So cosecant of theta equals r over y. Secant of theta is r over x. And cotangent of theta equals x over y. All right, so to begin with, we need to draw in a 150 degree angle. And so when we look at our 150 degree angle here, 150 degree angle is going to come around like this. It's going to look like that. And so we're going to have a point here. This is 150 degrees. And so that means the reference angle is going to be 30. So we have a 30, 60, 90 degree triangle that we're working with. The easiest way to do that is to let the short side be 1, which means the long leg is going to be square root of 3, and the hypotenuse is going to be 2. When we do the coordinate, remember that we need to think about the signs. And so the y value is 1 in the second, it's positive in the second quadrant, and the x value is negative. And so 1 comma negative 3 is our x and our y, and then our radius is 2. So we go through and we just plug these in. So sine of 150 equals y over r, and so it's just going to be 1/2. Notice that it's positive because it's second quadrant. Cosine of 150 is going to be negative root 3 over 2. Again, it's negative because cosine's negative in the second quadrant. And then tangent of 150 is going to equal 1 over negative 3, which is y over x. And remember, we can simplify that to negative root 3 over 3 by multiplying the top and the bottom by root 3. And then for the reciprocals, cosecant of theta, that's easy. Instead of 1 over 2, we get 2 over 1. Secant of theta is just going to be negative 2 over root 3, which gives me negative 2 root 3 over 3. And then the tangent, and these should all be 150 here, shouldn't they? The tangent of 150 degrees is just the reciprocal of this, which turns out to be negative 3 over 1, or negative root 3 over 1, or negative root 3. Now, please pay attention to these values. When you start seeing things like root 3 over 2 and root 3 over 3 in 1/2, please, 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 in your brain, that needs to get connected very tightly with 30, 60, 90 degree triangles. And now you've got to go through and figure it out on the sheet, but those need to be connected together. All right, so another one is going to be find the exact value when theta equals negative 135 degrees. So again, draw your coordinate grid. Negative 135 comes this direction, and it's going to be that, where this is going to be a 45 degree angle, right? 90 plus 45 is 135, so that means this is 45, which means my reference angle, the angle with the horizontal, that's acute, is going to be 45 degrees. So when I draw in my triangle, the easiest way to do it is let this be 1, let this be 1, and let the hypotenuse then be 2. So the coordinates of my point are -1, -1. And then the hypotenuse, the radius, is square root of 2. So when I do sine of -135, that's going to give you -1 over -1, which is +1. Remember we talked about sine, -1, my bad, I did that wrong, that's tangent. It's going to be -1, the y value over r, which is -1 over √2, which equals -√2 over 2. Cosine of -135, also -1 over √2, x over r, so -√2 over 2. And then the tangent of -135, that's the one I did at the beginning, which is -1 over -1, which just equals 1. And then we take the reciprocal of those, so the cosecant of -150 is just the reciprocal of -1 over √2, which is just -√2. Secant is the same thing. And then tangent, or cotangent, is simply the reciprocal of 1, which is 1. And so just like on the last problem, whenever you see things that have to do with square root of 2 in them or 1, that means you need to be thinking about, is this possibly a 45, 45, 90 degree triangle? Okay, another example is one like this, where you're given that the cosine of theta is equal to 12 over 13, and you know that 90 is less than or equal to theta is less than or equal to 360 degrees. So we know that theta is between 90 and 360 degrees. Remember what we talked about? If cosine is positive, that happens when the x-coordinate is positive. So this theta either needs to be in the first quadrant, which it can't be, because theta has to be greater than 90 degrees, or the fourth quadrant. So we know that we must be looking at theta in the fourth quadrant. So we draw a picture of theta in the fourth quadrant. Remember, this is x over r, and so our x value is going to be 12 of this point. We haven't figured out the y value yet, but we know that the distance is going to be 13. The radius is going to be 13. So we need to find y. Well, this turns out to be a classic 5, 12, 13 triangle. Y squared plus 12 squared equals 13 squared. Y would be 5. But notice, because it's in the fourth quadrant, the y value needs to be negative. Now, one thing I hope you're catching on to this is that you definitely will be held accountable for getting these negatives and positives correct. It's a big part of doing these accurately, is knowing when is my value positive, when is it negative. All right, now I just need to go through and find the rest of them. So the sine theta, we don't know what theta is. Theta is just this, that's the reference angle. It turns out that theta is this angle right here, right? And so, but we can just do it off of the reference angle. So sine of theta is going to equal -5y over r. Cosine theta, we already know, is 12 over 13. Tangent of theta, remember, tangent is negative in quadrant 4. And it just turns out to be y over x, which is -5/12. Looking at the reciprocals, the cosecant of theta just is -13 over 5. The secant of theta is just 13 over 12. And the tangent of theta is going to equal 12 over -5, or -12/5. Okay, another one, and you might want to pause the video here and try this one on your own. But this one, you're going to be given that the tangent of theta is equal to 1/7, and you're given that the cosine of theta is less than 0. And so we need to think about, where does this triangle go? Where does this coordinate go? First off, we know that tangent is y over x. So we know the y coordinate and the x coordinate are 1 and 7, or -1, -7, which tells us that theta either has to be in the first quadrant or the third quadrant. Well, in the first quadrant, cosine theta is positive. But this problem told me that cosine theta is negative, so this must be in the third quadrant. And so that's going to give me a y value of -1 and x value of -7, because tangent of theta, remember, is y over x. And so if y is -1 and tangent, it's going to look like this. -1, negative, or -7, -1. And then if you do the Pythagorean theorem, you get 7 squared plus 1 squared equals r squared, because we're trying to find, right, this is 1, this is 7. We're trying to find out what r is, and so that just turns out to be square root of 50, which is the same as 5 square root of 2. And so the radius for this problem is 5 square root of 2. So we go find all the other 5 functions. Sine y over r, so it's going to be negative 1, that's the y value, over 5 root 2, which just turns out to be negative root 2 over 10 when we simplify the radical. Cosine of theta is the same thing, except that it's negative 7 over 5 root 2. And so it just turns out to be negative 7 root 2 over 10. And then we do the reciprocals. Cosecant of theta just turns out to be negative 5 root 2, right? The reciprocal of this is that flipped over, which is 5 root 2 over negative 1, which is negative 5 root 2. Secant of theta is the reciprocal of this, and so it's just going to be negative 5 root 2 over 7. We already know the tangent of theta is 1/7, so that means the cotangent of theta just turns out to be 7. And so that are some examples from 12.3. We'll do another video, so a few more examples that you need to make sure you know how to do.